How's it going, everybody? In this video I'm going to cover a pretty simple topic briefly called frame relay. I've been getting a lot of requests through my YouTube channel and via my email address with issues where people don't know how to either get frame relay set up inside of GNS3, or they're trying to get traffic to route via frame and they don't know exactly how to set it up, or you've never dealt with it inside of GNS3. This is going to be a tutorial on how to do it with both the frame relay switch, which you see right here, and with a router that's acting as a frame relay switch, which if you follow any of the CCIE vendors, usually they use for the version 4 lab exam, they typically use a backbone router with a 8-port serial card in it, and they do all the frame relay through there. So what I'm going to do is I'm going to show you how to set up frame relay and ping via frame relay and show you how that works. So it shouldn't take too long to get through this. So basically what I'm going to do is what we're going to do is we're going to set up mappings in the frame switch, where we're going to set it up to where it's going to be a full mesh. Full mesh meaning every router will be able to talk to every other router. So R5 itself is going to be a frame relay switch as well. This is the frame relay switch you will get with GNS3. If you click on the switch over here, and you click right here, that's where you're going to find that. With a router, you can simply click on any router that's in here, and if it's got the capability of having either, if we go to configure, right click on it, go to configure, click on R5, go to slots, you can either go down to the HWIC itself and add up to 3 2-port cards, so you can have up to 6 ports, or you can add a network module 4T. The 4T is going to be your 4-port serial card. So we're going to use that for R5, which you can see they're all connected. So what we're going to do is we're going to go to our frame relay 1, and we're going to configure this as a frame switch. Now here, let me pause the video and I'll come back with the DELC numbers as they should be. Now here's the thing, when it comes to the way frame relay actually works with GNS3 and in the real world, what you'll find is we have a mapping. So 102 will be 102, 103, 104 will be router 1's way of getting to 102 will be to get to router 2, 103 will be to get to router 3, and 104 will be a way for our 1 to get to 4. So it's 1 to 2, 1 to 3, and 1 to 4. And on the reverse side, you have 2 to 1, 2 to 3, 2 to 4. You never map to yourself, because that would be a loop and it wouldn't work. So you have 2 to 1, 2 to 3, 2 to 4. We have 3 to 2, 3 to 4, 3 to 1. We have 4 to 1, 4 to 2, 4 to 3. So that's what we're going to configure. But it's going to be a little different when we get into the frame switch versus what's in here. So we're going to double click on this guy, bring up the node configuration. So we're going to slide this guy over and click on frame relay 1. Now the first thing you want to do is you want to make sure you're mapping it correctly. So I always go based on the router that I'm trying to generate traffic from. So we're going to go from port 1. I'm going to tab down to 102 and type in 102. The destination port is going to be 2, and that port number is going to be 201. So I just reverse them. So port 1 connects to router 1, port 2 connects to router 2, and we have DELC 102, so from router 1 to router 2, and then destination traffic, what it's going to do if we click on add. Now if we reverse it, what's going to end up happening is if we were to click on port 2 and go 201 and go port 1 and 201, or I'm sorry, 102, it's going to say mapping is already defined. Because the way that GNS3 does it is going to be a two-way mapping address. It's saying if any traffic comes in on port 1 that is destined to port 2, that's going to be from router 1 to router 2. Now it works in the same direction as well, or in the reverse direction. So if I want to go from router 2 to router 1, I'm going to come in on 201, I'm going to leave on 102. So it's a two-way mapping. So you don't have to do this, you don't have to map it both ways. What I would do is I would go 1, now we're going to go do from router 1 to router 3. So 103, 3, and 301. Click on add, and that's all you have to do. And you just continue to do this. We're going to go router 1, we're going to go 4, and we're going to go 401. So what this now does is it gives us mappings to, or I'm sorry, 40, yeah, it's already there. Sorry, I was looking ahead. So we have from router 1 to router 2, from router 1 to router 3, and from router 1 to router 4. Then we have from router 2 to router 1, router 3 to router 1, router 4 to router 1. So that's how the mapping statements would work. So I'm going to continue to do this until all of them are mapped. So we're going to go to port 2, we're going to type in 203 because we don't want to map back to router 1. We're going to go 3, and we're going to 3 is going to be 302. We're going to add that. Then we're going to click on 2 here, tab down to 4, and type in 402. We're just reversing the mappings. So it's whatever the local router is and whatever the remote router is. Okay, so 2 is local, remote is 4. Remote or local is 4, remote is 2. So we click on add, there we have it. So now on 3, what we're going to do, since we have mappings to them already, we're going to just, for 3, we can't map back to 2 because we've already got the mapping in there. Same thing with router 4. So, or I'm sorry, from 2 to 4. So from router 3, we're going to type in 304, go down to 4, and the mapping is already there. Click on add. So now we're fully mapped. Because of the way that it works here, you would build it like this. So we have router 1 to router 2, 1 to 3, 1 to 4, we have 2 to 3, 2 to 4, and then we have from 4 to 3. We don't have to go in there and type in 4 to 3 because it's already there. It just reverses it. So we're going to click on apply. Okay. Now if we hover, we might have to add. So what I'm going to do is from here, serial 0/0. I'm going to click on port 1. I'm going to come over here 2 to 2, and from 3 to 3, and from 4 to 4, respectively. Now if we hover, it may not do it. Oh, that would stink. Oh, there it goes. So there we have our mappings. So it automatically will adjust the mappings for us. So normally that's how you would type it in. Okay, so it says incoming DLC 104 is switched to port 4, outgoing DLC 401. So it automatically does it, even though the config is that simple. We simplify the config, but in reality, that's what it looks like. So now what we can do is, if I wanted to click on R1, and I want to do a, let's see here, show IP interface brief. So they're both, let's see here. Okay, so what's happening now is the connections are coming up because frame relay is in the process of coming up. So serial 0/0 is up. And I would expect that because of the fact of the way that it's working. So we'll be able to, from here, from R1 we don't do any configuration other than show run interface serial 0/0. We simply turn encapsulation on. We say encapsulation frame relay, and we put an IP address. There's a lot more you can do with frame relay. I'm just trying to give you an idea of how to get it up and running. So now what we can do is a show frame relay mapping, and what it's going to do is it's going to allow us to learn connections to who we have. So we do a show ARP. Right now it's empty, but if we try to ping 10.1.2.3, we're going to know how to get there. Same thing if we do go to router 2. Nothing's there yet. Oh, it's there now, but I'm going to do 4, and it's there. So show frame map. We have mapping statements in there now that says if I want to get to router 2, I'm going to use DLC 102 to get there. If I want to get to router 3's address, I'm going to use DLC 103 to get there. If I want to get to router 4, I'm going to use router 4's DLC, or the DLC 104 to get there. Now the same thing happens on both sides. So now if you see, we have traffic coming in and out, things are working the way that they're supposed to be. Now if we were to go to router 2, okay, so I'm up on serial 0/0, show frame map. I'm going to have the same mappings. So I have from 2 to 1, 2 to 3, 2 to 4. Now if I want to ping 10.1.2.4, so from router 2 to router 4, I'll be able to do that. So I have a full mesh of connectivity between router 2 and router 4. They're going to appear as they're directly connected because this is acting as a layer 2 switch, just like a normal layer 2 switch like a 2950 or 2960 would. A DLC is a layer 2 address, just like frame relay is a layer 2 forwarding protocol. Not so much a protocol, but it's layer 2 forwarding capability. So we have full mesh of connectivity. So we were to ping, actually let's do it this way, ping 10.1.2.255, I should get responses from all three routers. So routers 1, 3, and 4. What I just did with that ping to the broadcast address of the subnet is what they commonly refer to as a Smurf attack. Smurf attack is when you ping the broadcast IP address of any known subnet, and what you do is you get responses in from everything on that subnet, because it's what they call an all-host broadcast IP address, and if you ping that, anybody that's listening for that IP address on the network or on the LAN segment will respond to it. So it's a good way for you to test to see who's out there. So that's the frame relay switch. So in this next part, what I'm going to do is I'm going to show you how to set up a router as a frame relay device. So it's actually pretty easy. It's a little bit more complicated than using the frame relay switch over here, but because we're all, if you're watching this video series or watching the CCNP route series, I'm assuming you want to become a CCNP. Now, frame relay is becoming an older technology. It's been around for 20 some years. I know a lot of, in the area that I live in, Milwaukee, a lot of companies are migrating off of frame relay to MPLS. So, from that perspective, what a lot of times you'll see is people will migrate off of frame to some other type of newer circuit. But I'm going to show you how to set up frame relay here. It's actually really, really easy. You just have to understand what it is that you need to apply. So let me just bring this down here just so that you can see that this is the interface map markings that I have. So bring up R5. First thing you need to do is go to global config and type in frame relay question mark and switching. So that enables frame relay switching to happen. So you type in that control, and that's all we have to do to get it started. Now, that enables the capability of frame relay switching. Now what we have to do, this is where it gets a little more complicated. So I'm going to extend this out just a little bit because it's the configuration gets a little long in the wind. So let me drag this over here, close that out. Drag this over here, bring up R5 again, and spread this out. Because it does get a little long in the wind, especially when we get into some of the deeper config. So what I'm going to do is I'm going to go to the interface. So interface serial 1/0. First thing we need to type in is encapsulation is frame relay. The very first thing you have to type in, because then it won't. If you don't type that in, it won't respond to the encapsulated packets properly. So the first thing you have to type is interface, or I'm sorry, frame relay, and we have quite a few options here, and I'll give you the configuration that you need. First thing we're going to have to do is type in interface type, and it's going to be intf-type, and we have three options: DCE, DTE, and I'm not sure what NNI is, but we need it to be DCE, as data clocking equipment. And so from here, what we're going to do is we're typing clock rate is going to be some arbitrary numbers like 128. So that'll be what we need to do. Now, here's where it gets a little complicated. When you have that set up, what you need to do then is you need to set up your mapping statements. So what I'm actually going to do is I'm going to type in do show run interface serial 0/1/0. What I'm going to do is I'm going to copy this. Actually, I'm going to type in no shutdown and do the same command again. So what I'm going to do is I'm going to, that brings the interface up, and I'm going to copy this information. And I'm going to go to interface serial 1/1, copy, no shut. Do the same thing to 1/2, no shut, and right click, bring that in, and 1/3, no shut, and right click. There we go. Alright, so now we have our interfaces are up. So we do a do show frame route. Right now we don't have anything configured to route. So what this command would do is it would allow you to see the input interface, the input delc, the output interface, the output delc, and the status. So the first thing we're going to do is we're going to go back to interface serial 1/0 and type in frame relay question mark, and down here at the bottom you'll have the command that says route. So frame relay route for PBC switching. So type in route and input delc to be switched. So we're going to say we're going to do 102 because that's going to be the interface that's going to be the incoming delc on that interface. Question mark the interface, and it's going to be serial, and then the serial 1/0 I believe. Question mark, and then the output delc, or I'm sorry, is going to be 201. Question mark. Oh no, I'm mistaken. This one is this guy. So what this basically says is, let me hit enter and hit that up arrow a couple times. So now what it says is the input interface is this guy right here. So serial 1/0. The input delc is 102. The output interface is serial 1/1, which is this guy right here, pointing to router 2, and that input delc is 201. So what we're going to do is we're just going to repeat this over and over and over again until we have the correct mappings for each outgoing interface. So 1/2, and we're going to erase that and go 3. Hit the up arrow again, and we're going to do 104, going to 1/3, and then 401. So that's all we have to do. Now if we hit the up arrow a couple more times, we have serial 1/0 going incoming delc is 102, outgoing interface is serial 1/1, output delc is 201, and it repeats itself. So then we do that for every interface that we're going to receive frame relay on. So now what I'm going to do is I'm going to go to interface serial 1/1, and I'm going to hit the up arrow. And what we're going to do is we're going to say the incoming delc is going to be 201, and the outgoing delc is going to be 0, and that's going to be 102. Now if we hit the do show frame route, now we have a reverse mapping. So unlike with the frame relay switch here, which you can basically cut down your config, you actually have to go through the legwork of actually setting this stuff up. So now we have serial 1/0, 102, the 201. Then we have the reverse mapping, saying if anything comes in on serial 1/1, so from router 2 going to router 1, we're going to use the input delc of 201, send it to serial 1/0 using 102. And we're going to continue to do that for the entire setup. So we'll do 203, and we'll go, this will be 1/2, and this will be 302. That's why I keep this right here, because it's easier to reference. We'll do that, and then we'll hit the up arrow again in 204, and that'll be 1/3, and this one will be 402. So do show frame route, and so you can see some things are coming up because the interfaces are they're up and running. I've already got the IP addressing already in place. So we have 102 to 201 is active, and we have from 201 to 102 is active. So the two-way mappings that are there are up and running. Everything's running. So if we were to go to say R1, and see, you can see serial 0/1 changed to up. If we were to do a show frame map, we're actually going to have a couple mappings in here. Now if you see right here, serial 0/1 to 10.1.1.2, so that's using this router 5, it's active. So if I want to ping to 10.1.1.2, it's going to work. So that's that. So now what we're going to do is we're going to continue right along, and 1/2, which is going to be for router 3. Hit the up arrow a couple times. We're going to do from 301, the outgoing interface is going to be 0, and then 103. And the sequence redoes itself over and over again until you have it completely done. And this will be 203. Now there is another way to do this. You could do the initial configuration on, say, the interface serial 1/0 and 1/1. Copy that information, so do a show run on both interfaces, and you can copy that information in. So if we were to let's just finish up this interface real quick, and I'll show you what I mean, because sometimes it's easier to see what I'm talking about that way. So we have that one, and we have 403. So do show frame route. So now we have a bunch of active connections because we're starting to get mapping statements working and up and running. We still have to do serial 1/3. But as you can see, a lot of stuff is going active, which means mappings are working. If you see anything other than active, something's not correct. Whether it's deleted, inactive, or I forget what the other code is. But that should tell you what your configuration should look like. So do show run interface serial 1/0. You could do this. You could copy this information right here. Open Notepad. So let's bring Notepad over here. We could right click and paste, and then what we could do is we'll paste this again. Paste. So now what you could do, once you have the mapping statement, mapping information here, is you could go, we're gonna erase this and type in 401, 402, and 403. We're gonna go to the interfaces that map according to those, so serial 1/0, 1/1, and 1/2, and we're going to change the delcy that they would use to get to us. So from here, it would be 401 it would be 104, and then if we had 1/0, it would be 204, and if we had this guy, it would be 304. So you could do this. This is another legitimate way to handle the traffic, but a lot of times you'll see a lot of CCIE guys that are using a frame relay switch, especially for the older version 3 and version 4 map blueprints. Frame relay has been removed in the version 5 blueprint, so that's why it's not as commonly used. So what I'm going to do is I'm going to copy this. I just wanted to show you a couple of different ways you could do this. And I am in 1/3, and what I can do is I can just right click. Oh, it didn't work. There it goes. So when we do show frame route, just a matter of time now before it comes up, and we are completely active. So every router has connections to everybody else, which is a good sign because of the fact of the way that it's set up. So now if we were to go to, say, router 1, or let's go to router 2, and line protocol is up. Now if we do a show frame map, we're going to have connections on both serial 0/0 and 0/1. So we have connections through frame relay here and frame relay down here. The only difference between the two is we are using the frame relay switch up here to simplify our configuration. If you really want to understand how a service provider would do it, this is how it would do it. Now, one thing that I have done in the past, which I'm not going to demonstrate here, but I have set it up to where I've had a frame relay switch here and then another frame relay switch here. One thing that I have found is when you deal with more than one frame relay switch in GNS3 at a time, it starts to bug out because it doesn't have the capability of separating instances. It's going to map them all at the same time. So if you're going to build your network diagram to be what it is in GNS3 when you set it up to. So if you're going to be labbing it up, like if you're going to follow like Internet Network Expert, IP Expert, CBT Nuggets, Train Signal, if you're going to follow any of the vendors out there and you're going to have their logical setup look like it's going to be in GNS3, your best bet is to understand how it's physically configured and then do a logical application to that in a different drawing. So my best recommendation for you is to use the physical cabling, like you could do it like this, or you could separate it into a logical diagram to where it's the way it's actually going to be configured. However you want to do it is fine, but the way that I typically do it is I will build it physically the way that they would, you would have to, like in a Visio document, you would go in there and you'd say you've got router, 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 router. So if the routers were all lined up like this, for instance, so if you had all your routers stacked like this, and then you had a frame relay switch up top, that's physically how it would be in a rack, and that's physically how it more than likely would be cabled. But logically, it would look like this. This would be the logical representation of it. So if you want to do it, however you want to do it, it's up to you. But if you're going to use one frame relay or one GNS3 version frame relay switch, I would recommend using one of these guys, and then if you have a frame relay connection over here, for instance, and another one down over here, and another one up over here, have them all connecting to the same frame relay cloud, if you will, or configure a router to do it. Find a cheap router, a low resource utilization router, and use that. But it's up to you how you want to do it. But now you know how to set up a frame relay switch. Again, if we end out here and do a show run, I'll give you a brief overview of what we've done so you guys can look at the config and understand what you're looking at. First thing we typed in was frame relay switching to turn the capability of that on the router. Then what we did is we go to all of the interfaces that will potentially be acting as a connection down to an end user or a edge router, and we turn encapsulation frame relay on. We tell it that it's going to be interface type DCE for clocking. We set the clock rate on the interface, and we then say frame relay route. There are newer ways to do it. If we go to global config and type in frame relay, well, maybe not. I think it's in newer iOS images. You can do for connect. Yeah, it's is it connect? Serial interface number 1/0. Okay, yeah, you could use connect, and then you could use 102, and then you could say the outbound one will be serial 1/1, and then the outgoing delcy would be 201. You could do it this way as well. This kind of cuts down on what you've got to deal with, but I find it easier to do it underneath the interface because it pretty much gives you a blow-by-blow what it wants you to do. So you could do this, and it says route already exists for that delcy, connect invalid segment 1. So you could use it this direction as well, but that's another option for you. However, I prefer to do it through the interface level configuration, because then if something blows up on you and you do something wrong, it's going to squawk at you. So I would follow the configuration that I have here and go that route. And if you have any questions, feel free to send me an email or post on my YouTube channel. I'll be happy to help you out however I can. I hope this has been informative for you, and I want to thank you for viewing.